All right, so let's make sure we understand these properties of exponents because there are a few rules that we follow when we're dealing with simplifying expressions that have exponents. All right, so there are 7 rules to follow. There's your zero power rule, your negative exponent rule, your product rule, quotient rule, power rule, raising a product to a power rule, raising a quotient to a power rule, right? And sometimes you might see these as the zero property, right? Same thing. And then there's also scientific notation, which is a combination of either the product rule and or your quotient rule, depending upon if the number is bigger than one or smaller than one. So, I'll talk more about these rules as we look at some of these practice questions. But we have quite a few practice questions, right? Because I want to make sure that we're able to hit up on all of these rules. So I want to get going with these practice questions, all right? So when you're simplifying these expressions, right? You have to make sure you follow in PEMDAS so that you can make sure that everything is getting done correctly. All right. So the first thing I'm gonna look at when I'm looking at this is okay. We're trying to multiply these two expressions together, and so I know that that's going to be your product rule, right? Because the solution to multiplication, the answer to multiplication is called the product. So my 5 or my 3 doesn't have any exponents attached to them. So that's basically just multiplication, right? And then I see I have a base of A and a base of A. So the product rule says when my base is the same, I can just take the exponents and I can add them together, right? And then the same thing with my B's, right? Because I have a base of B over here and a base of B over here. So I can just add those as well. Okay, so now I can go ahead and just simplify this. 5 times 3 is going to give me 15, a to the ninth, b to the sixth, right? So one of the mistakes that happen seldomly is students multiply, right? They say, well, 4 times 5 is going to give me 20. Well, that's when you apply the power rule, but this isn't a power being raised to a power per se. All right, so now let's look at our power over a product rule, right? Because this -3 times t times w is multiplication, and then it's being raised to a power. Therefore, everything in this parentheses must be raised to this power of 4. All right, so hold on, this is kind of thick. All right, so that's basically going to say -3. Notice I'm in parentheses, raised to the 4th, times t, raised to the 4th, times w, raised to the 4th. Now I said, making sure you're paying attention to these parentheses because this -3 is in parentheses. Therefore, it's -1 times 3 4 times, right? So when I take a negative and I raise it to a positive power, when it's in parentheses, right, the solution will be positive. Okay, if this didn't have parentheses, right, like if this was written like so, if this was written as -3 raised to the 4th without parentheses, now that solution will end up being negative, right? And I'm going to show you just using my calculator real quick so that you guys can see that -3 to the 4th power is what, 81. So if I don't use parentheses, it's going to give me -81. But if I use my parentheses, it's going to give me positive 81. And again, that's just because, how do you write -3? If you were expanding it, it's really saying -1 times 3, right? And so when I have the parentheses, I'm doing that 4 times, right? When I don't have the parentheses, only the 3, only the 3 is being raised to the 4th. The -1 is just waiting to attach to it, following PEMDAS. After you do your exponents, then you do your multiplication. All right. So just wanted to make sure that we're clear on that because it's important when you have parentheses as opposed to when you do not have parentheses. All right. So we see that -3 raised to the 4th power is going to give us a positive 81. And then this just becomes t to the 4th, w to the 4th. All right. And so we have a few things going on here. Okay. So again, we have that same thing. We have the raising of a power product over a product rule, right? But we also have a special rule because we have a zero power rule, right? And so before I do 3, I'm going to jump to 4 just so you can see why this rule applies to number 3. All right, so number 4, we're going to apply our quotient rule, okay? And that's because we have division. Anytime you see a fraction bar, we have division, right? So the 4 and the 6, we're not going to touch. I mean, we're going to simplify that here in a second. But the quotient rule says if my bases are the same, like the product rule, well, then I can just subtract the exponents, right? So I can subtract my x's, I can subtract those y's, and so now I can get 2/3, right? When I simplify that, x to the second, y to the third. All right. Now I said that because, you know, our zero power rule says anything to the 0 power is just going to equal 1. And here's why. If I say 5 divided by 5, kind of looking back at our quotient rule, these 5s are raised to the imaginary power of 1. So if I just apply my quotient rule to 5 divided by 5, I'm going to say 1 minus 1, which is going to be 5 to the 0, which equals 1. That's why this rule holds true, right? So anything to the 0 power is going to be 1. So if we do what we did in question 2 to question 3, where we go ahead and raise everything to that power of 0, we get 15 to the 0, x to the 0, y to the 5 times 0, right? Which is just going to be 0. So this is just basically going to be 1 times 1 times 1, which gives us a solution of 1, right? So this whole thing is just going to be the solution of 1. All right, so moving on, we click off and scroll down here to these next 4 questions. Okay, so question 5 is, again, we're just looking at our quotient rule. Okay, so we're looking at our quotient rule because we have the bases the same and we're doing division. So we're just going to say x 5 minus 1, right? Because this is to the imaginary power of 1. Therefore, we get a solution of x to the 4th. All right, and number 6 is, again, raising of a power over a quotient rule, but it's raising to the power of 0. So it's basically becoming y to the 0 over 3 to the 0, which is just 1 over 1, which gives us the solution 1. All right, so number 7 can be a little tricky if you're not paying attention, okay? So first things first is that this negative 2m to the negative 4 is not attached to this m to the 4 raised to the 6, right? So I'm saying that because I don't want you to think that, oh, I got to take this 6 and put it into the 2 and put it into the negative 4 and then the positive 4. No, no, no. That's only attached to what's in the parentheses. So here's where I say, like, you got to make sure, you know, you're following your order of operations to make sure you get this stuff done correctly. Because before we can start combining these m's, we need to first do our power rule, right? So this is going to become negative 2m to the negative 4 m to the 4 times 6, right? Because that's what my power rule says. So I get negative 2m to the negative 4 m to the 24th, right? And because this is multiplication, like, you know, there's 2 ways you can look at this. You can say, well, I know that my negative exponent rule says I need to reciprocate that. So this becomes negative 2 times 1 over m to the 4th times m to the 24th, which is going to give me negative 2m to the 24th over m to the 4th. And now I just got to apply my quotient rule, which is negative 2m to the 24th minus 4, which gives me negative 2m to the 20th, right? And that would be the solution. Or we could have just applied our product rule, right? We could have just applied our product rule to this question right here. Or when we got to this point, once we went on ahead and did our power rule, we could have just said, oh, okay, well, my product rule says if my bases are the same, I just combine my exponents, right? And now negative 4 plus 20 is 24 is just going to give me a positive 20, right? So I get the same solution regardless of which way I decide to take it with my rules. All right, question 8. It looks like we are doing a power over a quotient rule again, right? And so we're going to say A is going to be raised to the fourth. So when I'm saying A is being raised to the fourth, like again, I'm following my power rule because I know A is to the imaginary power of 1. And when I'm raising it to the power of 4, I'm just saying times 4. And then that's over 6 to the imaginary power of 1 times 4 times B, the imaginary power of 1 times 4. And so all this becomes A to the fourth over 6 to the fourth, B to the fourth, right? And so I'm going to use my calculator to figure out what is 6 to the fourth. Sorry, I clicked on something wrong. Let me find my sheet that I just lost here. Give me 1 second. All right. So we're going to say 6 to the fourth power is going to give us 1296. So we're going to get A to the fourth over 1296 B to the fourth. All right, so I'm going to pause right there so that if you have to go back and review any of these first 8 questions we looked at, and I'm going to pick it up in another video where we can complete the rest of this worksheet. Talk to you shortly.